So welcome. This is the second day of our evidence and evaluation conference. I'm really excited to see just the level of appetite and the number of people who have signed up for today and also for our conference session yesterday. My name is Dr Eliza Kozman. I'm Deputy Director of Research at Taiso, and I look after the research and evaluation programme. Before we get going, I'm just going to kick off with some housekeeping. So just to let you know, you are all muted and you aren't able to see each other. This is the webinar format of Zoom, so don't be distressed if you can't see each other. That's what's going on here. This session doesn't have a Q&A section at the end, so please do defer any questions. If you'd like to follow up, I'm very happy to take questions via email, but we're going to press straight on afterwards into the more substantive sessions of the day. I'd like to let you know that we are recording this session and we will be distributing the recording and the slides to attendees afterwards. So you'll see the little recording icon on the screen. And we'll also be seeking your feedback. So please look out for some feedback emails in your inbox over the coming days. We really value any feedback you can give us about how we can do this better next time. So please do give us your thoughts. Yesterday we had a really exciting first day to our conference. We had session discussions on how HE can help us build back better after COVID, discussions around evidence use in policy. We heard from other WhatWorks centres to give us a roadmap for how Taiso could help the HE sector. We also had sessions on our work with mature learners and on race equality gaps. And for those of you who haven't seen already, we launched a new report on our work with mature learners, which is available on our website. So please do take a look at that today if you haven't had a chance to already. But today is a little bit different. So the second day of our conference is a bit more practical and a bit more focused on the how of evaluation. So how do we evaluate? How do we produce more evidence, which essentially will help us answer the question of how to close equality gaps, which is what we're all interested in. And if you're here today, you may be a bit more focused on the front end of developing that evidence and evaluation, or you just might want to find out more about how to do that. So I hope we can answer some of those questions for you. After my introduction, which will last about 30-35 minutes, we're going to let you move on to other sessions. There are a number of free parallel sessions here today, all of which will be recorded. And so you'll be able to follow up on anything you're not able to watch today by accessing it via our website later on. So I hope that's helpful. But with no further ado, I'm going to share my screen in a time-honoured way, and we'll see if I can show you my presentation. So I'm really hoping you can see my slides at this point, because there are no panelists to tell me whether that's working. So the title of this presentation is about correlation versus causation, but very briefly before we start, I just want to introduce you to Taiso. So if you're here on this call, you probably know a little bit about us already, but as a reminder, we're set up as an independent hub to help the sector access evidence and evaluation techniques to help close equality gaps in higher education. Anywhere there's inequality, we're interested in addressing it. So from access through to success on course, retention, and then out the other side into employment and further study outcomes as well. That's all the full student journey is where we're hoping to add value. We are an independent charity, so we recently spun out of King's College London, a big step for Taiso, and we've been set up by King's College London, Nottingham Trent University, and the Behavioural Insights team. We are an affiliate WhatWorks centre and part of the UK government's WhatWorks movement. And as I mentioned yesterday, there are lots of other WhatWorks centres working in parallel sectors. We're really hoping we can replicate their success with the higher education community. And we're funded by the Office for Students from 2019 through to 2023. In terms of our motivation, why we exist, our vision is to eliminate equality gaps in higher education, as I mentioned, anywhere they exist in that student journey. And we want to do that by using evidence-informed practice in HE. So we're all about how we use evidence and evaluation to close those gaps. That's what really drives our purpose. But today, what I wanted to do was take a bit of a step back. So this is probably quite a fundamental presentation to give, and it's really around, I suppose, research literacy, understanding the kind of evidence which TASO is going to hopefully help the sector produce. And so I wanted to talk about correlation versus causation. But why do I want to talk about correlation versus causation? Well, as hopefully I've just demonstrated, what we really want to know is what are the best ways of addressing inequality in access and success. That's really the question we're trying to answer through all of our work, our evidence synthesis, our research projects. We want to find out the most effective approaches so that we can help the sector understand and use those in their work. How do we do that? Well, one of the things we do is our evidence synthesis activities, so running evidence reviews, literature reviews to try and understand what we already know and what we don't know. And we've launched a number of reports in the last year. This is report number 1, which we launched back in last January, so January 2020. And this is a literature review of the evidence on how to address inequality in access to HE, which we worked with the Education Policy Institute on. And this is a quote from it. We find that most of the studies find positive but modest effects, but there are gaps in the evidence base, and often the evidence doesn't demonstrate causality. Article 2, this is a second report. We published this in last autumn term, and this was looking at the evidence base for activities to close equality gaps post-entry to HE, so once learners in higher education. And again, we have this quote, there are some gaps in the research and it often doesn't demonstrate causality. Exhibit number 3, this is another report. We published this in this January, as some of you may have attended our launch, and we find that this is relating to learners with experience of children's social care. Small sample sizes and gaps in data coverage hinder the development of robust causal studies. So what we're seeing across the piece, and what we talk about a lot, is we've got some evidence, yes, but we have some really big gaps, particularly when it comes to causal evidence or causal studies. And so the fact that we talk about this so much made me want to just do a presentation on it, address this, make sure we all have a really good understanding of what we mean by causal evidence. And that's hopefully what I will give you an introduction to today. A caveat up front, or a disclaimer, I suppose, is that there are lots of ways of talking about this. So causal evidence, causality, causal attribution, and causal inference, these are all getting at the same idea, which is really what we're trying to understand is cause and effect. Does activity A cause outcome B? So whenever you see this causal phrase being used, that's what we're getting at. So don't be deterred by all these different expressions. But before we talk about causation, I'd like to start by talking about correlation, because this is the well-known maxim is that correlation doesn't imply causation. So what do we mean by correlation? Why doesn't this imply causation? And how can we use our critical skills to identify when correlation isn't causation, basically. So I'm going to take you through a few examples of this. Some of them are a bit more fun. I'm hoping they'll just stick in your brain and be useful. And then I'll try and tie them back to some more relevant examples for the HE community in particular. But this is very much a foundation piece. So there's lots more to learn about correlation versus causation after this session. So let's start with a definition. Correlation means there is a relationship between two variables. So by variable, I mean anything that can be varied, could be heat, could be height, could be grades, could be HE progression. And what I'm going to do throughout this presentation is talk about variable A and variable B. So variable A and variable B, we're going to use this little icon at the bottom of the screen to say that there's some kind of correlation between the A and B, and we're using that little link there to demonstrate that there's some kind of pattern. What we mean by a correlation is that when A changes, so does B. There's some kind of connection between them that means that either when A goes up, B goes up, or when A goes up, B goes down. So something is happening, which means those two things move together. And I'll put some more concrete things into the A and B box as we go. But just to demonstrate that up front, that's what we're after. So there are lots of different types of correlation. This is, let's say we're going to plot A and B on our graph. So we've got some nice axes there, and we plot A and B on there as a scatter graph. I'm not going to use loads and loads of graphs throughout the session today, but I am going to just demonstrate. Sorry, I think somebody's got their hand up, but I'm not able to see. Let me just see if I can find that. That seems to have disappeared. If there's a problem, then hopefully that will come through. Apologies. Are you able to still see my screen? I'm unaware of what you're able to see, which is not a great place for me to be. Perhaps someone could just send me a message to let me know if there's a problem. This is a bit like a nightmare. Okay. Oh, you can see everything. Can you still see the slides? Oh, good. Thank you so much. I can't see which slide you're on. So if I press my next button, I might have to just stop sharing and reshare. Okay, fine. Let's do this. Advanced sharing options. Or, oh, don't do that. Types of correlation. Pause recording. I'm so sorry, everybody. Please bear with me. Okay. Slides are showing fine. Okay, great. I'm hoping that you're just on slide 12. It's not showing me the red box anymore. Yes, okay, great. Thank you for all being so nice. Okay, so here we have different types of correlation on the screen. So on the left-hand side of the screen, we can see that there's, if we plotted A and B on our nice clean axis like this, we have a perfect straight line between A and B, which is basically telling us there's a perfect positive correlation between the two. On the left-hand side, on the right-hand side of the screen, we have the opposite. So when A goes up, B goes down, and we have a perfect positive correlation. And then you can have all kinds of correlations in between. So in the middle of the screen there, you'll see all the dots are just mixed up. There's no particular pattern, which means there's no correlation between them. So when we're talking about correlations between two variables, this is basically all we mean. There's some kind of pattern, which means that when one goes up, the other goes down, or vice versa. And that's just all we're getting at. I'm sure all of you will be familiar with this kind of stuff from perhaps GCSE education or a long time ago, but always worth a refresher. Okay, I'm hoping it's moved to the next slide now. A key caveat here, or a warning here, is to be really careful though. So patterns are beguiling. And our brains would love to find patterns in the data, particularly when they support our beliefs. So when we see a nice straight line, it can instantly trigger us to try and describe that with a reason or a description of what's happening. But we have to be really alive to that and make sure that we're not inadvertently describing things in a way that supports what our brain wants to believe. And that's really what I'll be getting at today. Okay. And the way I'm going to demonstrate that is to use the examples of the dangers of ice cream. We're moving into warmer weather now, so I really wanted to flag just how dangerous ice cream could be before it led to any adverse outcomes for all of you. Some of you may have seen this example if you have a social science background. Sorry if it's familiar, but I think it serves a really good purpose for us learning about this today. So this is a graph of ice cream sales along the left-hand side on the y-axis and murder rates along the x-axis. And what we can see in reference to the slide I've just shown you is that we actually have a positive correlation between murder rates and the number of ice cream sold. So something is happening when the ice cream sold goes up, the murder rate also goes up. And that's a pretty surprising correlation to see. perhaps, and should we be worried about it? Does this mean there's some kind of spooky correlation between ice cream and murder rate? This is data from New York City, although it appears to be an apocryphal study. If someone can find the original reference, then I'd be very glad for them sharing it. And the story doesn't get any better when we start looking at drowning deaths. So this is a graph of drowning deaths on the left-hand axis and ice cream production on the bottom axis. And we can see again, we've got this really not very happy correlation between drowning deaths and ice cream production. So what's going on here? And do we need to be very worried about eating ice cream? Is there a dangerous link between ice cream, murder, and drowning? Now here, what we're really getting at is we can see there's some kind of link, some kind of pattern, some kind of correlation between these things. But does ice cream cause murder and drowning? Because that's what we really care about. And when people start worrying about whether ice cream should be banned or not, for example, that's really what we're trying to understand is the ice cream the causal factor here? And what I want to present to you today is this way of thinking about causal claims. So this is what we're calling the causal claim checklist, or the causality checklist. And whenever you see a causal claim, I would encourage you to go through these three things. So to consider whether there's a coincidence happening, whether this is reverse causation, and the role of confounders. And I'm going to just describe each of those in turn. So coincidence, first of all, and this is probably the easiest one to understand. Coincidence is just when there's a pattern in the data that's happened kind of by mistake or by fluke. Coincidences happen all the time. So are we just seeing some kind of coincidental pattern? This is a graph from a website that shows spurious correlations, basically. And it's a graph of maths doctorates awarded and uranium stored at US nuclear power plants. Yes, I can see someone's put the link there. And you can see there is a spooky correlation between these two things. They track really nicely over time. But I don't think anyone's claiming that the number of maths doctorates awarded has led to this change in uranium stored. So it's just one of those flukes that comes out in the data. Here's another one. Divorce rates in Maine correlate really nicely with per capita consumption of margarine. But I don't think we're going to suggest that margarine causes divorce rates in Maine, although there could be arguments that happen over that. So we're just seeing a coincidental correlation in the data. And finally, another food-based one. This is per capita consumption of mozzarella cheese and civil engineering doctorates awarded. Really nicely correlated in this data. Got to be a coincidence. It's just a fluke. And there are lots of other examples that you can have a look at online. A lot of them are to do with murder and deaths, but I took them out because I already had enough murder in my prior example. So if we look at our causation checklist and we think about the ice cream and the death link, could it just be a coincidence? So we look at our first bit in our causation checklist, and it could be a coincidence. There might just be a coincidental correlation here. So we're going to put a question mark in that box for now, not sure. Item number 2 on the causality checklist is reverse causation. So when we have two variables, A and B, and we have them linked like this with our little chain, we've got A on the left and B on the right. When we write them out like this, often what we're thinking is, does A cause B? And reverse correlation is just about thinking, well, actually, could it be the other way around? So could B actually be causing A? And we have to consider that possibility. These are a couple of fairly simple examples, but they serve to demonstrate a point. So number 1 at the top, we have a link between winter coat usage and cold weather. When one goes up, the other goes up. But it's fairly trivial for us to consider, well, it's probably not winter coat usage driving the cold weather, right? It's the other way around. So we can draw the arrow of causality from cold weather to winter coat usage. That's quite a straightforward example. The second example of wind blowing and windmill turning is probably very obvious to grown-ups, but my background's actually in science education. And this is one of those typical misconceptions that can really flummox some kids, because it seems like the windmill turning might actually be causing the wind to blow. So perhaps not as trivial for everybody, but this way around, we can obviously draw that arrow of causality from the wind blowing to the windmill turning. So in the top example, it's B causing A, and in the bottom example, it's A causing B. So reverse causation is just a reminder to consider that it could be the other way around. So going to our causation checklist, do we think that murder and drowning leads to increased ice cream consumption? I think it's highly unlikely. I can't think of a theory of change as to why that would happen. So we're going to put a cross in that box. Item number 3 on our causation checklist is really I think the most interesting one for us today. And that's the role of confounders or confounding variables. So this is really where the meat is, I suppose, for the HE community. And confounding variables is when something else is causing both A and B to change at the same time. So in our simple model, we've got A, we've got B, we've got a link between them. But when we have a confounding variable, there's something else which is causing both A and B to change at the same time, something else outside of that relationship. So let's just use our example of the ice creams, murders and drowning to think about this. And I think we could be on the cusp of uncovering the cause of this correlation here. Well, the confounding variable here is the culprit is actually sunshine. So, and I'll explain why. So when the sun comes out, the number of ice cream sales increases. We all go outside and we eat ice creams. We're also more likely to go outside. And it turns out that when you go outside, the homicide rate increases and violent crime increases. So there is a literature which suggests that weather is related to, or violent crime is related to weather, because just being outside and in groups and in crowds leads to higher rates of interaction between people who can hurt each other. So that appears to be the dominant mechanism there. There is also some suggestion of being hot and bothered, but I think it's more the going outside factor from what I've read. And then, of course, the extension of that is when it's sunny, we're more likely to go swimming, and so drowning rates increase. So we can see that it's not that these 3 things in our blue box are linked, it's there's something else outside of that relationship, which is independently influencing all of those things at the same time. And we call that a confounding variable. And in this case, it's sunshine. So we go back to our causation checklist and we find that, yes, there's definitely a confounder here. We'll put a tick in that box. I think we're going to rule out coincidence now because there's a good explanation from confounders. And so here we can probably cancel the ice cream ban. It seems very unlikely that ice cream is causing those bad outcomes. Now that's a bit of a fun example. As I say, it's a bit of a typical social science example. But the overarching message from that is that before we can make an unreserved causal claim about some kind of relationship, so A causing B, we really need to be considering these different things that could be driving the pattern. So is it a coincidence? Is there some kind of reverse causation going on? Instead of A causing B, does B cause A? And are there some kind of confounders that we haven't considered? Some kind of other factor that's influencing both A and B at the same time. That's the kind of theoretical introduction, I suppose. And what I'll do now is I'll try and make that a bit more relevant and more kind of real for the audience today by tying it to some examples which I hope are more relevant to the HE sector. So let's consider 3 examples in turn. So I'm going to take each time a statement that someone's made, or we can extract from the existing literature, and then consider whether we can extrapolate from that to make a causal statement. So statement number 1 is that students with a tutor have poorer grades than those without a tutor. And there are parallels here with our recent work looking at mentoring as well, where we found there was some mixed evidence on the correlation between taking part in mentoring and HE entry outcomes and attainment. So the causal claim here might be, if we were just to take it on face value and not think about it too much, our causal question might be, does having a tutor cause lower grades? Now that might seem a bit silly to those of you who work on the ground, perhaps running tutoring programs or know how they work, but that would be a very simple reading of that correlation. So we have tutor on the left-hand side, and we've got lower grades on the right-hand side. Having a tutor does appear to be correlated with having lower grades. But when we go through our causation checklist, I think there's a good reason to suspect that there could be some reverse causation going on here. So rather than having a tutor causing lower grades, having lower grades could cause you to be more likely to have a tutor, because if you've got lower grades, you're more likely to seek out a tutor, or you might be opted into a tutoring program, or you might be given a preferential place on a tutoring program. So here, if we look at our causation checklist, we're probably going to put a tick in the middle box, because it's likely that causation is flowing the other way. Could be other stuff going on. This is just an illustrative example to kind of get the juices flowing. But I think this is a good example of where it could be from B to A rather than from A to B. Number two is an example of outreach. So this is a big question for Taiso. The statement here is that participation in outreach is associated with higher HE attendance. And this is something we've done work on recently, and we do see it in the data. The causal question is, does outreach cause higher HE attendance? So we've got outreach on the left, HE attendance on the right, some kind of connection there. When one goes up, the other one goes up as well. But the thing we have to be really careful with here is those pesky confounding variables. And I think the two key ones for us are student motivation and school support. There may be lots of others, but I really want to focus in on those. So let's think about a student who is highly motivated to attend higher education. They could be also much more motivated to take part in outreach. They could opt in for summer schools, apply for as many as possible. They could turn up at all the after school sessions they're offered. And so that factor is going to drive up the outreach, the bit on the left-hand side. And it's also going to mean they have a higher level of HE attendance than someone who is less motivated. So that's driving up both sides of our equation. By the same token, let's think about school support. So a student in a school that's very supportive of going to HE is going to help that student to attend more outreach sessions, and then that student's more likely to go to HE as well because of that school support which exists. So we've got these confounding factors or variables which are driving up both of those things concurrently. So when we look at our causation checklist, we put a big box in the confounding circle there. Really important for us to take into consideration. And if you'd like to read more about our recent work on this with the Higher Education Access Tracker, we released a report a few weeks ago, which you can access on our website. So you can see we do see a correlation between taking part in outreach and these positive outcomes, so key stage 4 attainment and HE progression, but we have to caveat them really carefully with this issue of confounding variables. This is my example number 3, my final example. And the statement here from the literature is that the more books in a household, the stronger the academic performance of children in the family. So the causal question is, do books cause higher grades? Got books on the left and grades on the right. When one goes up, so does the other. But if we added more books to the equation, would the grades go up? Is that what's going to happen? And here, the important thing again is to consider those confounding variables, confounding factors. And I think a really key one is the role of parental support. So let's consider why that household has so many books. Are parents buying those books? Does that reflect their values and the amount of time and money they have to support their children's learning? And if it does, then that parental support is going to independently affect both the number of books in the home and the grades of the children who live there. So we really need to be considering that, and we have to put a big tick in our box in the causality checklist. Arguably, There's also some kind of reverse causation that could be happening here. So, you know, perhaps if you've got higher grades, it's more fun for you to buy books. It's more aligned with your social identity, and it feels better to have those in your home. So we'll put a tick in that box as well. I'm not going into loads of details on these examples. We could probably debate them and kind of have really interesting discussion about each of them. But just to give you a taste of the kind of things that we should be considering. And why does that matter? So why do we care about understanding whether something is causal or not? Well, I want to bring you back to the question that Taiso is trying to answer, which is what are the best ways of addressing inequality in access and success? And I think we have to be able to answer those causal questions in order to do that. So if we look back at that last example of books and grades, if we're not thinking about causality, then we might assume that if we change the number of books, we buy children books, and there are some schemes that do this, so kind of book gifting programs. We might assume if we change those books, then grades are going to go up. But of course, hopefully what I've just demonstrated is that buying those books doesn't change the underlying thing that really matters, which is that parental support, that home environment, all of those, that other context, which is really the thing which is simultaneously driving both the number of books and the number of grades at the same time. So without delving into that in more detail, we might miss the real cause of any positive or negative effects, or we might get a partial picture of what's going on. And that makes it really hard for us to identify the most effective approaches to supporting learners. So really what we're often trying to get at is this causal question, which underlies the evaluations that we're doing. So what can we do? Hopefully I've demonstrated that it's a bit trickier than just looking at correlations. Correlations are a good place to start, by the way. Without a correlation, perhaps you wouldn't even delve into things in more detail. Really important to have that empirical data. But the next step is about using and choosing research and evaluation methods which allow us to address that issue of causality and really get under the skin of it. I'm going to say right now that I've made this look very straightforward. We have A and we have B, and we have a nice straight arrow between them. And that obviously belies the complexity of the situation. Causality can be very complex. There are different ways of understanding causality. That's a different presentation for a different presenter. But I just want to give you the kind of intro to or foundation piece on causality, which I think is so important to understand kind of why we're driving for more causal evidence in the sector. And I suppose that the other question is to why care at a meta level about this? Well, you can of course have a good evaluation without exploring causality. Your evaluation might not be looking at causal questions, but I would argue if you're trying to talk about impact, you really do need to be considering causality and causation in your evaluation. That's what impact evaluation is trying to do. So, and the fact that we are all motivated by having the biggest possible impact on equality gaps means that I think we need to just explore how different methods can help us do that. We align with the OFS standards of evidence, which I've put here on the screen in front of us. And just to tie it back to that, for the purposes of those of you who also align with the standards of evidence in your work, I think on type 1, we've got good work on this. We have good narrative evidence. People are using theories of change more and more and describing why we expect interventions to be effective. On type 2 evidence, that's empirical research, we have some of this and we're getting better at collecting data, all kinds of data, and trying to really understand whether there are correlations or associations between participation in activities and outcomes. But we are still missing this type 3 evidence. It's a real missing piece of the puzzle, as I demonstrated with our various reports. So that's where Taiso can hopefully come in. We also want to support more of good type 1 and type 2, but hopefully we can really help bolster the type 3 as well, because there's just a little bit less of that available. So how can we help develop causal evidence? Well, we have presentations today which will hopefully help answer that question. We have 3 presentations this morning directly following this. We have Dr. Sonia Ely from the University of Cambridge, who's going to talk about quasi-experiments that can help you answer more causal questions. We have Professor Chris Fox and Dr. Jessica Ozan from Manchester Metropolitan University talking about how we can do this where we have smaller samples of learners, which can be more challenging to use some causal impact evaluation methodologies. And then we have Dr. Ben Stiles from NFBR talking about randomized control trials, which can also help us create more causal impact evidence. Following those presentations, we also have presentations from the Taiso team, which are more practical again, so focusing on theory of change and also survey design and validity, and will hopefully get you more under the skin of that kind of day-to-day work to evaluate activities in the sector. But for now, I'm going to wrap up, hopefully on time, to give you time to progress to the next sessions, which I'm sure you're all signed up for. Thank you so much for your attention and for bearing with me while I thought none of you could see me as well, which is, I will be having nightmares about that later. If any of you do have questions, please do feel free to email the Taiso team following this session, and I'll be sure to follow up with each of it individually. And we'll be distributing these presentation slides following the session as well. So thank you very much and have a brilliant day.